Hello and welcome to the final part of the AI series. So previously we got set up our village with some basic behaviors there where they could be gathering resources and we could prioritize different things. And so what we're going to be doing is building on top of that, because what we had set up was the villagers had perfect knowledge within a range. So we want to change that. We don't want them to have perfect knowledge anymore. We want to restrict that to a narrow radius. But we need to be able to then have them discover resources, which that's going to require a couple of things to be able to make that happen efficiently. So, firstly, we need to handle this situation of if they don't actually have enough resources or they can't find ones. So what we're going to do is, for the village, change, first of all, that perfect knowledge range to, say, 25. But then that's not enough. We need to adjust the behaviors, because that now means that we could have cases where there aren't resources it can find. So what we're going to do is we're going to set up for our particular gather setups. So for the gather action, previously we had set up so that if it failed to pick a resource, it could repick. We'll actually get rid of that. It's not going to repick anymore. What it will do is it will actually flag that it has finished. This way, that action will stop running. And that's good, but we also really want the goal to not happen either in that case. So we've already got a few mechanisms we could make use of for this. One of them being this gather a priority. If that comes through a 0, that goal's not going to run. So we could set up so that the village itself is saying whether or not we've got enough resources to gather. So we could set up an int min resources to allow gathering. We might say that we need at least 20. Then we also want to be able to keep track of the number of resources we've got known to us. So int num known or num available resources. And that we want other things to easily be able to get it, but nothing else to set up. And we can update that. So we have our setup here. We're already populating our resources in that short range. So we can just add in the ones that we have discovered. So that's good. We've got our number of available resources. We've got our threshold. That means we can just check here if there are insufficient resources to gather yet. So F num available resources is less than that min. We just return 0. So having the gathering stop until we've got enough resources, really easy. That's the easy part of this. The more difficult part is efficiently finding all of the resources, because we could take our resources and on all of the prefabs, we could add in so that they are now a detectable target. And we've already got our detectable target manager. The AIs themselves have that ability to track resources. If we take a look at the villager, they already have this awareness system and everything, but we have a lot of resources here. And it's a lot of resources. If we were checking against all of those all the time, it's going to be really bad performance. And that's something where we could overhaul the detectable target manager, change the internal data structures it uses. Using something like a tree structure would be quite efficient there. We also can actually change it that the AI builds up its own local awareness. So rather than just having our detectable target manager, we could actually have a localized version of that. So we could set up so we have a local detectable target manager. And the idea is going to be that this is something which sits on top of our AIs, so that rather than our AI having to talk to that central one, if it's got a localized one, which we'll add that in here, if it's got that localized one, it's going to prioritize that, which is the overall sort of goal we're after for it. So it's going to be similar in that it's going to need these key functions. So we're going to bring these over, but a lot of these are then going to get deleted because we won't need them. So we don't need start and update, and we don't need any of the stuff for it being a singleton. Register and deregister, well, those are actually going to change to on trigger enter and on trigger exit. Because this is actually one of the easiest ways to build up a known list of things around you is actually using the physics system. And so what we do, collider, and we can do stuff where we can go, well, other, game object, get component in parent. We try to retrieve a detectable target so that we can store in target. And we can say, well, okay, if that target was found, so it's not null, and we don't already have it being tracked in our list, then we add it. And then the logic down here is similar, except we don't have the logic where what we're doing is checking if it already contains it. So collider other. So what we can do then is here, it's just checking if it is not null. So that's good. We've got a local detectable target manager. And what we want is this to take priority over the detectable target manager. So in something like the vision sensor here, I want that list to come from the local detectable target manager if we've got one. So we're going to say local detectable target manager. We're going to retrieve that here. So target manager is equal to a get component of one. And the proximity sensor is going to need the exact same logic because proximity sensor also uses that list of targets. So it gets these as well. And then what we do here is, okay, well, we know we're going to have a list detectable targets, and this is going to be the targets. So if the target manager is not equal to null, then this becomes targets, all targets. Target manager, all targets. Otherwise, we use what we had before where it's going to the parent one, or the global one. So this just gives us a really easy way of, if there's a local one, it takes priority and we use it. So we use that smaller sort of awareness, and then that changes in vision sensor as well. So that's good. And we could do stuff where it could even merge between the two of these. That would be a very doable thing. So then this could set up a bool, serious field bool, local target manager only, which will set to false, just so we can control whether this gets run or not. So if it is not local target manager only, then we'll do that. Same logic for down here. This allows us to, in our resources, these resources are only going to be discoverable via the local one. So, okay, our resources will have the local data. Our AIs have their target managers. That should mean that with reasonable performance, our AIs are able to actually wander around and find these targets. So we'll let it run. And so they're in their idle to begin with. That's what we expect. They're wandering around. Performance is decent, which is good. And we can see they're going to be saying things like that they saw food, stuff like that, which is great. So they are managing to fully detect things. That means we can now start feeding that information through. So what I'm going to do is we don't need these open anymore. Where that detection and everything happens, if we take a look at our villager, then we'll be able to see where they're getting their data from. We'll see that they have an enemy AI script. So this is the one that's controlling the updating of things, everything like of that. So what I want to do is enemy AI, that one was being used in the first and person one as well. I want to actually set up, so I've got this base AI script that I want to get up and running, and I want to then also be able to have a separate villager AI. So what we're going to do is refactor a bunch of stuff from enemy AI into the base one, and things that were dependent upon the base AI. So the enemy AI will now be dependent upon the base AI. So it just gives us a bit more of a flexible setup, which will work well. And essentially everything from enemy AI is able to go over at this stage. So all of these can be brought over, replace the entirety of that. Now there are a bunch of things here that we will end up making virtual. We'll get to that soon. That means we can remove the content of this and just say that it's based on base AI, which is good. Our custom gizmos here we can bring over, and this is actually going to be for base AI. So it just means that's a bit of a better setup, which is good. So we've got our base AI, enemy AI is based on that. Now our various functions here, like reporting that stuff can be seen, things like of that, those talk to our awareness system. So our awareness is going to become protected. All of these as well. We want to just make these protected because the child classes may need those. So just really useful to have them be accessible. So that's good. Our different functions here, so in particular, ones like of this, for stuff being on suspicious, things like of that, those are ones that we want to have be virtual, because these are ones where they actually need to have customization typically in those child classes. So the other ones we won't mark as virtual, but these ones that are indicating those state changes, these we will have as virtual. Because for the enemy AI, we'll use those sets of ones, and these will all be override. Because the enemy AI one, these have a tone, the messages are already indicating that, what they're seeing is a threat. So that's fine, we want that. Whereas for the base one, we actually don't want any of these messages. We want to leave it up to the individual customized version of the AI to make that call. That's good. We could also mark this as abstract, just in case we need to force any particular things to be implemented. We don't have anything at this stage, but if we did, it gives us a way of doing that. This then also changes. We don't need any Unity editor stuff here. We also don't need TextMesh Pro at this stage. So our enemy AI is much, much simpler. Our villager AI is going to be quite similar. It's going to be like that. We will bring over all of these functions for now. We're not going to necessarily use all of them. but we'll bring these over. So it's based on base AI. We won't worry about stuff like herd. We will say that it can see things. And we'll actually just have it not in undetected, but only in on fully detected. And if it lost detection, we won't say anything. So we might say I last saw, and then it can indicate if it fully lost everything, then what we'll do is just set it to be blank. So it can just be an empty string. So we're not displaying as much information intentionally. We want to find anything that was referring to enemy AI before, and this is now going to be base AI. So all of these change to using base AI, including things like the require component. We don't want those to require the enemy AI. We want it to only be the base one, so it's going to make it a little bit more generic, which is good. So we are having to do quite a few changes, but it sets us up for then being able to expand upon this later in a much more easier, quicker way, which is really the goal. So we've got those set up, our awareness system, so that looks good. That means now if we look at our villager, so our villager still's got the enemy AI script, but we're going to give them the villager AI. And it's a child, similar, like they have a common parent, but we probably won't be able to paste those values in, which is as expected. But we can open the prefab, and then with the prefab, we can easily link over that. Can get rid of enemy AI. 60 and 30 for the range seems reasonable. Our villager does need a way of being able to detect the things though, because we haven't actually given it that. So we're going to give it a sphere collider, because this is for the local detectable target manager. We'll mark that a trigger. And if our vision cone range is 30, I'm going to make this 30 as well. So now our characters should be able to pick up stuff. They'll output what resource they've found. So we just want to test that. Again, make sure that they're reporting seeing things. We should see the little speech bubbles above their heads change. So we can see a bunch of them have seen food, which makes sense because there is food nearby. So that's good. So they're reporting that they've found stuff. Now they just need to tell their AI, the owning village. So the villager AI, well, we can grab the AI state. So AI state, linked AI state. Now base AI, we don't have anything in start and update, and I will actually get rid of those. So this, we will have void start, linked AI state, and we can retrieve that because that's sitting on this object, which is good. What that means is then when we have fully detected something, we can go, well, hey, linked AI state, home, saw resource. But we need to know that we have definitely seen a particular resource. So what we would do is world resource, found resource, and F target try get component for world resource. Then we tell it that it saw that. So we use try get component because that will avoid an allocation if that component was not found. So we add that target. That means the village, if we get back to it, we can set up a function here, public void, and it will be saw resource, world resource, resource. Now we need to check if we've already got that, because we might. So F, tracked resources, resource dot type contains that resource. So if it doesn't contain it, then what we do is we add it. So we say, okay, add resource, and then num available resources can go up. So this is going to pass that through. That becomes found resource. So it should mean that the AI awareness is able to build up. Okay, so let's test this out. So this village here in particular, we know they can't gather to begin with. There's not enough resources. We can see that they are managing to see ones, which is good. And we can see a bunch more wandering around. And as they wander, the village will acquire more resources, which means it should hit the point where some of these then want to actually try and gather a resource, which is good. So it'll take it a little bit before it actually hits that point. And it needs to gather enough to be over that threshold. Once it does, we can see it's got the goal of gathering the resource, but that's not becoming active. And there's a reason for that. When we designed this, when we set it up firstly, it was with perfect knowledge. We could acquire and find every type of resource in range. Our gather target doesn't handle if there's none of a particular resource type present. So if we look, this will go through and it's just looking based on the number of gatherers, not if we actually have any of this resource type. So what we want to do is F, and we can check tracked resources, resource type. So F that resource type, and this is something where like value, we're going to actually make this a little bit easier to work with. I'm going to say here, type value, and we'll go var world, resource type. That just makes this a little bit cleaner interface-wise later on. So F tracked resources for that is equal to 0, then we're going to skip. So if there are none of this resource type, then we don't pick that as a target. Then we skip. Now that also means that our default resource here, we could conceivably get that wrong. I think though, this will actually be sufficient that what will happen is, our number of gatherers, whatever value we get is always going to be lower than this. So the first time we hit anything where we've got number of that to gather, it will be fine. So let's test this again, and we should see more reliably now what happens is not only do they go into that gather goal, but they actually do successfully go and actually run and perform that gathering. So we'll just expand out our village 1. They're just doing their idle, now they're going and wandering. So they'll be building up their set of resources. It'll take a little bit before we see gather resource kick in, but it shouldn't take too long. As soon as it hits that threshold number of 20 resources, then it's going to kick in and we can see gathering resource. So that's actually running. It's found particular ones. It's going and collecting them. So in this case, picking up some food, returning and taking that back. So we've now got our system where we're managing to discover information and gather resources. So if the AI doesn't have enough information to start off with, it goes and acquires it, which is great. So final little bits that we want to add in is, because we're collecting resources, stuff like that, it'd be nice to see and know how much of a particular resource we have got. So what I'm going to do is for the actual village, if we open up the village prefab, then we're going to give the village a little bit of UI. So we'll give it a canvas that will make world space, and general approach I use for world space canvases is what I would do is I would set the width and height to reasonable values. So I think something like 800 by 400 feels about right. And then I adjust these scales. So 0.01, something like of that. We'll create a panel within that so we can easily see it. So that looks about right. So village UI. And then we can reposition this. So we can move that up a bit. Like of there. So probably about 8. It's pretty good. So what we can then do with this is in that panel there, what would be nice to know is essentially our resource levels. So let's add in another panel within that what this panel is going to have. So resource levels or resource panel. We're going to have 2 things in here. We're going to, 3 things actually. We need text for the type. So this is going to be stuff like water, food, wood, like of that. We'll also have in this, we'll chuck in on the right-hand side an amount, which let's assume, let's budget for, that looks plenty. And then finally, we will chuck in there a slider, because sliders are a great way for doing like a little progress bar type thing, but we'll turn that off of being interactable, and that will let us sort of control the appearance with this. So we'll anchor that to the top. We'll drop the height to 100. Let's reposition all of these. This is where we could use something like a layout group, but I think we can do this without really needing a layout group, because this one's going to be positioned there, maybe like 10, maybe even 20. We definitely can drop the height of this probably to 50, 75. That looks good. So type, we have that left aligned but vertically centered, whereas amount is going to be right aligned, also vertically centered. We position it and mirroring the offsets we were setting here, that would be -20. Width of these two is probably going to be about the same. So you can see probably 100, maybe 150. Because then our slider, we have it expand to the full area, but we adjust left and right like that. And the top and bottom, probably give this a little bit of a larger size. I think we can go larger again, just so it's taking up a bit more space, looking a little better. So that looks pretty good. We would get rid of the little sort of handle that it has. So turn that off. And we just want to check with this slider, its value can go from 0 to 1. So we do need to slightly tweak the fill a little bit because it doesn't quite fill the whole way. We'll just test again. So that value looks pretty good. So min and max value, we would say, we might actually reduce that amount. Let's say we can't store any more than 1,000. That might be the maximum capacity that we have. So that would mean the slider goes from 0 to 1,000, whole numbers only. That looks pretty good. So we can connect this up for the different resources. What I would generally do is give this its own dedicated script. So village resource panel, or village UI. And we can add that onto the actual panel. Because we made a lot of the information available, it's going to be pretty easy for us retrieving this stuff. So this is going to need to know, we'll need our text mesh pro. We're going to bring in text mesh pro UGUI. So resource type. We need one for resource amount. And we will then also have for that slider, so we'll also bring in unityengine.ui, unityengine UI, and our slider resource slider, or resource progress. So then this, well, we can find the village, because we can also give this a link to the village. It can just directly talk to it. Linked village. So what we want to be able to do is update these particular things. So the resource, and we'd actually provide the particular resource type here. So I would actually do something like world resource eType resource type, because that means we can then set our resource type label. That becomes resource type. Convert that to a string, which is good. The resource amount, well, what I want to be able to do is say, okay, well, linked village amount stored resource type. So get amount stored, and that's going to come back as an integer, which also allows us to then say, okay, well, the resource progress, its value is going to be the same thing. So we set it initially in start, so we can also then update these here. And what I would do is check if the stuff is actually changed, so that we're not running it every single time. That's just going to make this a little bit easier. So we would do amount stored like that. Saves us running the function all the time, and it'll also mean later on we can filter the amount of times we're needing to update the UI, because we can set up here current amount equal to linked village get amount stored for the resource type, and f current amount is not equal to this, then we'll just update it. And then update these. Resource one, we would probably need to do, no, actually we can just use value. It's fine for it to do send a notify. That's not going to be an issue. So the village now needs to be able to tell us, well, how much have you got stored for a particular resource? So it's going to need public int eType type. So, okay, that's good. Now it's keeping track of what ones it knows about, but not about how much it's got stored, which that's fine, because we can set up int resources stored, and we'll initialize that. And down here, where we're going through and doing some initial setup of stuff, what we can do is populate these values initially. So this is something where this loop here, I'm going to actually bring this over just to populate the initial amounts that we have got stored. So we'd be able to say then that amount stored, which is going to be our resources stored. So that we just need to do a little bit of a cast of our value is equal to 0. So nothing stored to begin with. Nothing stored to begin with, but we could populate that with an initial amount. We could randomize that. There's a lot of different things we could very easily do there. Get amount stored is then really easy. We just return that. So, okay, we now know the amount that we have stored. We'll set up our different resource panel elements here. So it needs to know the village. We'll say that this is water. Labels for type, things like that. Really quick and easy to link up. And our slider gets linked across as well. So this is going to be water, and then set up so we've got food and also wood. We just change the type and it will update the rest of the things. It will query that different info, which is good. And then the final thing we need is just to chuck in a vertical layout group. So we'll put that in, and we do want it to force expand in width. We don't want it to force expand in height. So that looks good, and we can shrink this panel now a bit as well. So it was fairly high for that UI, but we can reduce this to, it's probably going to be able to be something like 225. So it looks good. It's got some UI there that should update when we store resources. Now we haven't told it yet to be able to store resources, but that's an easy thing to add in. We can just add in public void store resource, world resource, the type, and the amount. So our stored resource, if we go to, what do we call it? We called it resources stored. So we do that, type plus equals amount, which is good. So we can go through, store that amount. Now our AI just needs to actually say when it's finished how much it has stored. So, okay, we go over to our gather action. So when this has finished, so at this point here where it goes and it says that it's finished, it could then go, okay, well, linked AI state, home, store resource. We know our resource type because we have our target. So we have the type, and then we just need the amount. So that would be something where, again, it could go in the AI state. So linked AI state, amount carried. If we have it linked so it's only able to carry a single amount of stuff at a point in time. So that means our linked AI state needs to know how much it's carrying. So again, we could set up here public int amount carried, private set. So that's good. We can store the amount carried, but we're not populating it. Well, it would get populated here when we finish collecting. So that's where the target could tell us how much it's actually provided. So we could say, okay, well, linked AI state, set amount carried to target available resource or available amount. Because this would allow us to have that change over time if we wanted. So that means set amount carried. We can update that over here and have a public void set amount carried. We just update it. So it's good. We can store the amount carried. We can, so we're setting that. We still need to get that available amount. The other thing we want to do is after we have offloaded it, then we're done. We're not carrying anything anymore, which is good. So that's good. Now we just need the targets of the world resource to be able to know its amount. So again, can have a public int, available amount, private set. So we're going to put that as 0 because what we'll do is have a randomized value for it. So serialized field, int, min amount, and we might say that that is 15, int, and a max amount, which is going to be, say, 50. So the available amount is going to be a random range between those two. That's good. So what this should mean is that our AIs will go and gather resources. The amount that that resource goes up by is going to be different. And we'll also see the stuff update for the village. So that's what we're going to be keeping an eye on. So we want to see these actually changing. So we can see it's getting a little grumpy that it couldn't find water. So if we go over to our village, so it means that there's nothing there stored for that. That probably means we actually need to do this initial population a little bit earlier. We probably need to do that in a wake. And that's fine. That's easy to do. We'll just put that here so that it's done nice and early. So that'll mean we've got those populated in there. So what we're looking for is the AIs will go out, they'll gather resources, they'll bring them back, and these values change. So we can see we've got our different types. None of these ones are currently gathering, but they will be soon. Our other village, which is from memory a little bit over the way. So we've got one village there, and there is another one hidden away. Village 2. So if we take a look at Village 2, they have had a bit more of a chance to be gathering things. So they have seen some resources, and we can see they're actually successfully gathering ones, and different amounts, because as they go and pick up stuff and bring it back, it will be different amounts that they actually find in each case. And if we go back to Village 1, by now it has managed to find stuff. So as expected, it found food and wood first, which means those stored those. We should see other ones start to go up a little bit. So it's going to run, sit there, store stuff. So wood went up a chunk, so it found a whole bunch of wood. So we've got it now that these are managing to go and find resources. They're building up their knowledge of the world by exploring the world. And this is where that wander goal then actually comes in really powerful, because wander is how they build up more knowledge. And then the fear aspect reins it in, pulls them back in closer. We have our resources generating random amounts. We could then have that stuff regrow. We could change the prioritization there as well. Thanks, folks. I hope you found the video helpful. If you're looking for the code for the project, then I've put the link for that in the description below. With all of the videos in this series, what I'm doing for that is each section it's tagged, so you can just go direct to that tag for the particular video. And if you've got questions, chuck in a comment below. If you want to submit them for the next Q&A video, there's a link to that in the description below as well. If you have found the video helpful, chuck in a like and subscribe. It's something that really helps out. It's really appreciated. And if you're looking for other ways to support the channel, I do have a Patreon, and the link for that's in the description below. Until next time, bye.